Hey everyone and welcome. In today's video, exploring data with Python. Today we also gonna learn NumPy and Pandas basics. These are all the topics we will cover in this presentation. So, today we are going to dive into the exciting world of the data with Python. We will be looking into two different incredible and powerful tools that makes works with data easy and fun. NumPy and Pandas. Don't worry, if you have never heard them, we are going to start from scratch. Let's go. First of all, why Python for data? You might be wondering why Python? Well, it's one of the most popular language for data analysis and for good reasons. It has a huge collection of special tools, all called libraries, that are built specifically for handling data. Think of them as a pre-made tools that saves you from having to build everything from scratch. These tools are used by different data scientists, researchers, and big companies all over the world to find patterns and make sense of the information. Here, I will show you simply which language is best. You can also search your own. Simply search here. Here you can see the primary language for data science is widely considered to be Python. And mostly for these different libraries, NumPy, Pandas, scikit-learn, matplotlib. Earlier we see the how to install different libraries, and today we will work with NumPy and Pandas. Now, before moving forward, starting the NumPy, I will show you how to install both the libraries. You can simply use command prompt, type cmd, enter. As in my earlier video, you how to install libraries. So again, I am showing you how to install libraries using command prompt. Simply search for cmd and press enter. You redirect to command prompt and type here pip install numpy. As you can see, I have already installed the numpy. That's why it is showing this. And similarly, you can install pandas. You can see there. I have installed the pandas libraries already. This is one of the simplest way to install different libraries in your system. Or you can also refer to different websites to install them. But I suggest you to use the command prompt to install this because it is easy and you can understand it quickly and you can install the libraries as you like. So first step is NumPy. The name itself gives you a hint. It stands for numerical Python. At its core, NumPy helps you to work with the numbers. Its main feature is something called an array. You can think of the NumPy array as a supercharged list that is built for doing maths really, really fast. If you have a massive list of numbers, a NumPy array is a much better choice than a regular Python list. Moving forward, now the NumPy array versus list. To understand the difference, imagine a regular Python list as a shopping list with a mix of items, a banana, a book, and a number 10. A NumPy array, on the other hand, is like a neat column of a number in a spreadsheet. The real magic is that you can apply a match operation to the entire array at once. For example, you can add 5 to every single number in your array, just one line of code. This is called vectorization, and it's what makes NumPy so powerful and fast for calculations. So now I will show you the practical how the NumPy array works and what are the features of the NumPy library. Simply type Anaconda, you open the Anaconda navigator. After opening the Anaconda navigator, you get this interface. Simply launch the Jupyter Notebook. I am creating a folder here, name as uh, course. Sorry, it's by mistake. Uh, Opening this folder, I have moved this. Now I am creating a new file, Jupyter file. Just you can rename from it. We will start with NumPy. Rename to NumPy. As in my earlier video, I have shown the working of the Jupyter Notebook. So in today's class, we will start. So in my earlier video, I have shown you how to use the Jupyter Notebook. So in my earlier video, I have shown you how to use the Jupyter Notebook. In this, we will start with NumPy. You can simply type as import. This import this is used to import different libraries or different functions, methods in your Python code. Import NumPy as NP. I am importing NumPy library as NP. I am giving it's simply a short name so I can use this in my code more easily. Now I am creating an array. Simply I named the array as N1. Simply type np dot array. I am using the NumPy as given. I have the np and the function array, and then I can create the array any number like that. This is the array, and for print you can simply write as print n1 and run this selected cell. You can see here the output. This is the array we just had created. You can also print by simply typing n1 without print function. In Jupyter Notebook, you can print it simply using the variable name. Run this. Here you can see it is full showing the array NumPy. It's an array and this is NumPy array. This is I am just adding a column outside. Just a second. I'll type here single dimensional array. Or in this, you can see there are two types of array, a single dimensional array or multi-dimensional array. This is the example of single dimensional array. In this, there is a single dimension you can see here, just a single array element. They are all the elements in a single call between the columns, square brackets. Now I will show the multi-dimensional array. Our name is as n2 and similarly np dot array, and you can hear 10, 20, and enter the different elements. And to separate two elements, you can use columns. And then simply here. Now you can see it's a multi-dimensional array. There is a one dimensional and it's a second dimension. It's a 2D array. Similarly, you can see some more functionalities of the NumPy. You can simply check is it really an array or not. Simply type. Using the type function, you can see the type of any integer, any variable. Simply type, and as we have named this array as n2, we are giving the function the variable parameter as n2. Simply run the column, run the selected column. You can see NumPy and the array. It's NumPy multi-dimensional array. You can also check for type n1. Just click runs the set NumPy and the array. It's a NumPy array. You can see here. You can also initialize the NumPy array with zeros. I will show you how to do this. Simply type import. We name is as entry dot zeros. Simply now entry. You can see here it's in this you can the second element is for the dimensionals, different dimensions, and the first element for the values that in which dimension it should be present. The values you can see if I change it 5 and with 5 you can see here. Oh sorry, just a second. I will remove this. Here you can see 5 dimensions, 5 different rows and 5 different columns. You can simply understand as a row and columns, 5 rows and 5 columns. You can change if you want, just try 10 and 10. You can see the size is increased. So you can also initialize the NumPy array with same number. Similarly, I'm just copying this here, and this now and 4. Just remove the zeros as we are not initializing with the zero. Type it as full. And now you have to give the dimensions. I'm starting with smaller, 2 and 2. And now you have to give the number, which number you want to initialize with. I'm giving 5, 20, and 4. Here you can see the 2 by 2 array in initialized with number 5. You can change the number as 10. Here you can see it's changed. You can also update this 5 to 2. You can see this 5 has changed. You can also change it 5. Then array is initialized with all the numbers. You can change as you wish. You can also initialize with array with a range. Here, I will show you. And just initializing. Just starting with copying this. You just have to remove this tool and just use the function arrange. And in this, you just simply have to give the array, array starting range, uh, like 10 to 20. Here we are printing alpha. You can see that the poll is also we are not using we don't use a multi-dimensional array in this in the range function. Simply enter. Here you can see there are total 10 elements because it's range starting from 10 to n minus 1. Uh, the range in Python goes to n minus 1. That's why it only goes to 19. The last element is n, and the range is always goes to n minus 1. Yeah, Python's range goes from a to n minus 1. This is element a. The first element is a, and for the last it goes to n minus 1. 20 minus 1, 19. That's why here is 19. You can also use this uh, just changing this array function starting from 5 to 50, and you can here this is starting element 5, last element is 50, and the range is n minus 1, so it goes to 5 to 49 only, and you can here give the space, the difference between the elements. I'm selecting for 5. You can see here the first element is 5, then after the jump of 5, the 10, 15, 25, and goes up to 45. As the 49 is the last element, it's not uh, the because of the difference is 5 only, it's not possible to add, add the 49 in the last. That's why the last element is 45. And 5, okay, we'll change this as M6. This is also there. And one more thing, you don't have to import again and again. I'm just showing you how to do it. If you have done import in the starting column, you can simply run this column and then run in the sequence. If you need uh, any library used, just import in single column, run that column, and you can use in any other columns the functionality of that library. So now if we have to just initialize the array with random numbers given in a range with random numbers. You can see, just I'll show you. For random numbers, just remove the array function, random. This is the function for the random selection or selecting the random numbers from for the array from the range. And, and now it's you can start from 5 or I start from 1. Let's increase the range to 100, and the minimum number gap between two numbers is there is 5, and change the 7 array. Just starting, you can see here this is the starting number. This is for the n number n minus 1. like a ring starting, and this is end, and when as soon we are selecting in this, and this is the total count of the elements in the array. 5, you can see 1, 2, 3, 4, and 5. 5 here. Oh, just sorry. 5. These are selected randomly. 93, 40, 53, 28, 89. If you want to check is it random or not, just run it again. Run the selected column. You can see it. The numbers are changed. 27, 24, 9, 37, 56. And it also showing the data type in 32. Just see. If you want to change again, just run the column again. You can see 6, 69, 23, 90, 45. You can see it's just changing randomly. You can also create array not only with numbers, you can also use different alphabets and characters. I will show you creating a multi-dimensional array of different things. Uh, as I have import earlier, I told you that we don't have to import again and again. So now I am simply starting with next number and it next array and three dot array and here oh, 1, 2, 3, 4, and 5 elements each and 20, 30, 40, 50. Now I show you um, the, the, for the digit or for the alphabetic characters, you have to use these symbols, double braces or single braces to use them as these are strings. For any string or any character values, you have to use this. So D for the fifth value, just simply print. And you can see without an error, it's showing the our entire array, multi-dimensional array. Now you can also check the shape of the array. You can check like any shape. Simply type shape and run the column. Here you can see 3 by 8, 3 rows, 5 columns each. That's why it's 3 by 8. And if we check for the type, and using the last array. Here you can see NumPy array. It's a NumPy array. So I think this is enough for the array function. And for the NumPy, you can see you can do many different things. There are many more different functions for the arrays are present in the NumPy library, like stack, vstack, hstack, column stack. Okay, I will show you these three also. Then I think these are good enough for now. And for the remaining functions, you can see on your own pace because the library is vast. I can cover the whole functionalities of this library in a single video. That's why we will start with vstack. Simply, we need two arrays for this. I am writing the whole code for this. Import numpy as np, creating first and one dot array. This is just np. Fifty, 50 and 60. Now for the vstack function, simply write np dot vstack stack n1 comma np, and then this one. Here you can see using the vstack function, these two arrays are simply combined, or you can say created into a multi-dimensional array. Just this vstack function added this array and this array in these two single dimensional array into a multi-dimensional array. This is one first element, the whole, and this is the second element. It combines the array. And now for H stack, I will copy this, simply paste here, and we simply change it to H stack from this command. You can see here it merges the two single dimensional array and created a third single dimensional array as well. It's a single dimensional array, but in VStack it creates a multi-dimensional array. But in STack it's a single dimensional array. And now for the column stack, just remove the name, type column underscore stack, and just run it. You can see here two columns and three rows. Here two two arrays. If you see like that, first row, second row, it simply changes the rows into columns, 10, 20, and 30. Here's the 10, 20, and 30, and 40, 50, 60, or the 40, 50, 60. It changes the rows to columns and columns to rows. So that's why it's changes to this form, two different arrays to this one. It's the column stack. I think this is enough for the NumPy. There are many more functions. We can talk in our future videos, I think. So Before moving forward, I think there are 3 to 4 more and very important functionalities which I have to taught you. Before moving forward, there are some very important functionality I forgot before, but these are the most important in the data science field, or we can call the working with data. These functionalities are very important. So I will show you one by one. Simply, we'll use this array only. Simply this, and to say here I add one more element 70, and in this also 70, and 40. Here we can have 70 and 90. I added some more elements just to show the different functionalities that are very important in the data science field, starting with intersection. Intersect one, this is one D N1, comma, and simply run this. You can see here the intersection. What the intersection told us. The intersection function told us the two common values which are present in both the arrays. Here the 40 and 70. Here is the 40 and here is the 70. You can see these two only values which are present in both the arrays. That's why there is only 40 and 70. Similarly, you can see the set difference in this np dot, or I can simply change this set difference, set difference one. Here we go. The set difference is 10, 20, and 30. The set difference shows the elements of the first array which are unique, which are not present in the second. That's why you can see only the 10, 20, and 30 here, not the 40 and 70, as these are present in second array also, 40 and 70. If we change here like n2 in starting and 1 in, then it will show the elements in the second array only, which are present in second array only, not in the first, as 50, 60, and 70. This is used, or this is the main function present in the set difference. And now I can use this array and show you some more and very important functionalities like mean, median, and mode. How you can see, how you can search or calculate the mean, median, and mode using the NumPy functionality. You can see here in NumPy, mean, median, and mode, there are simple methods. You can simply type as mean And then for the array, n1 as the we have created the n1 this array, simply type as np.mean. This is numpy dot mean n1 and run this code. You can see here this mean is given into float values, float 64. That's why it gives also the decimal values 34.0. This is the mean of this entire array. Similarly, you can check for median in this. See, the mean is 34 and the median is 30. And similarly, this is the standard deviation value in this. You can see these all comes in the float as value can be in the decimals also. This is 20.591260 this large. That's why it's in float value. You can see these are some very important functionalities of NumPy which we are going to use in our data science field and in our machine learning as well as the deep learning field also. You can do more functions on your own. I think this is now enough for today for the NumPy section. Now we are moving forward with the pandas. Here, meet pandas. Now, let's talk about pandas. If NumPy is a calculator, then pandas is our spreadsheet software. It's the ultimate tool for organizing and analyzing the data. Pandas' main structure are called series and data frames. A series is just a single column of data, but a data frame is a real star. A data frame is a two-dimensional table that looks just like a spreadsheet, complete with rows and columns. A data frame. What's a data? A data frame is a perfect for holding all the kinds of real world data, like a list of customers, sales, figures from a different companies, or even surgery results. The best part, each column can hold a different types of values or data. For instance, you call numbers, or you could have a column for names that can be in text values, or another column of age that can be a number value. Pandas make it super simple to import data from file like a CSV or direct into a data frame, so you can start working with it immediately. I will show you some examples of different data frames like the CSV files, etc. Simply open any browser and search here for any type of data. I will data frame. You can see here just like this. This is the data frame. There is the registered numbers, names, and mark sheet. This is the example of a data frame. You can see here. Simply go to images. I will show you some more. Here you can see It's example of a data frame. There is different columns, different rows, each column with different eh, data types. Like it's a string, here it's a number, it's a float value, it's a character, here again it's a string. You can see just like that. It's example of a data frame. Now moving forward, key operations with Panda. So what can you do with the data frame? You can have total control over your data. You can easily select specific columns or rows, just like in Excel sheet. You can filter your data to find only the information you need, like finding all the sales that happen in a specific month. And you can even handle messy and missing data, something that is very common in the real world examples or real world problems. Pandas gives you the tools to clean up and prepare your data for the analysis. For the pandas, I will show you some practical. Simply go to the Anaconda Navigator and launch the Jupyter notebook here. I will show you some functionality of the pandas in this course section. I'm creating a new file. In this file, I am renaming as a pandas. Rename it pandas. Just like the pandas, or just like the arrays in NumPy arrays, there are single dimensional array and multi-dimensional array as well. Like in this, for the single dimensional objects in the pandas are known as series objects, and for the multi-dimensional, the data is known as the data frames. Now moving forward, similarly, as we import the NumPy library, we will import pandas library, type as import pandas as PD. I'm using PD as a short form, and for the first data, S1 PD dot series, as we are making it single dimensional, a series data 12, 2, 3, 4, and 5. Simply print S1. Here you can see this is the data. This is the serial numbers. The serial number starts from the 0. You can change the serial number as well, but in this, by default, the serial number starts from 0, 1, 2, 3, and 4. And this is our data 1, 2, 3, and 4, 5. You can see here we have used the 1, 2, 3, 4, 5. If you want to see, I'll change the data simply by adding 0 and 9. The data is 10, 20, 30, 40, and 50. Now you can see the data is changed 20, 20, 30, 40, and 50. And it's also showing the data type. It's an integer data type. You can also see the type of this similarly as we see in the array. Simply type as well. In that, when we are working with array or the NumPy, at that time you can see the type it shows the it's the NumPy array, and in this it shows the pandas for series. It's a pandas function library, and it's a data type of series. Now some more. As I told you, you can change the default sequence number or the index. Now I will show you. You just have to change here, simply comma, and its index, as this is index equals to. You can set here anything you like. I will selecting for so how many there are? Five. I will using the alphabetic characters. B, sorry, D, C, D, and last E. You can see now I will change here. You can see here the index is changed to A, B, C, D, E, and the data is 10, 20, 30, and 40, 50. Here you can see the index is 0, 1, 2, 3, 4, 3, and 4, and the data is this. But in this, you have changed the index also. You can see using this, you can change to index like anything you can, or anything you want, you can change like that. And now for the two-dimensional data, or we call multi-dimensional, or the main about the data frames. Since we type import pandas as pd dot data frame, we have given the names. We follow up, select element, and just for the values for the another column, select note marks, and now speaking, sorry, 61 and 55. Simply you have to run it. You can see here it's a data frame. In Pandas, the data frame is one of the main and one of the most important functionalities of the Pandas. It is used everywhere in daily life, in the real world examples and the real world problems to solve or to make the data in proper shape and to prepare the data for advanced functionalities. Data frame is one of the most important function. You can also type as just like this. If you want to give a data frame a name, you can also type as like this df.pd.dataframe and here, and now you can simply print here, and the same is here. You can also give the name to a data frame. The first column is this, and after the comma, the second column is this, the name and the marks. Similarly, for using, if you use very large data set, we can use some more functions like head, describe, tail, shape. I will show you one by one, just using this data frame only. I know it's a bit smaller. I shall add some more in this. Inside board, and then marks, 90, 95, and just run it. Oh, just a second. Now run it. There you can see I added two more data rows in this. I will show you one by DA dot head. Simply run. In this, as the data frame is small, but the head function returns the top some of the top values of the data set. As the data set contains only five five rows, five different values, that's why it is showing the whole five values. If we add simply, if we copy them and add here, similarly like this, and run this. As you can see, the data is increased. Run here, you can see this is giving the values. You can set how many values you want. I set for 4. It's only gives the top 4 value to me. You can see the 4, the ADA. This is, you can select here how many values from the top you want. Then it uh, shows you, gives you only that values. And then for the bottom, you can use tail. Similarly, here you can see it is giving the elements from the bottom 98765, the last 5 elements. You can simply, I type S2, it gives me last 2 elements. If you want the data or you want to select the data from the top or you want to see which students or which are the data present on the top, you can use head function, and for the bottom you can use the tail function. Simply, if you want to describe the data, simply use the dot describe, and here it shows a proper description of each data. I will show one is five. And so here you can see this is the proper description. I by mistakenly entered 5 in between. Here you can see the total count, the total number of data from 0 to 9, it's total 10. So here the 10, and it shows the median standard deviation of the data, median, mean of the data, standard deviation of the data, minimum, which student have the minimum marks, the percentage of the 25% and 50%, 75% above, and the maximum marks is 95. You can see using describe function, this your data is described in proper manner. You can use this to see what the functionalities are present in your data. And one more, df dot shape. Yes, I have told you the shape. Here's the type. Okay. Now about the shape, just said it's not a tuple. Sorry, shape you can see 10 by 2. Here total elements are 10. Total elements or total rows are 10, and the columns are 2. This is its shape. One to name and marks, and total elements are 0 to 9, 10. Rows and columns. 10 rows, 2 columns. This is easy. You can see this is all the majorly used functions you will use or you have to use in the data science field to prepare the data for the functionalities of the NumPy library or any other libraries. Pandas library is used for this. I think for Pandas, this is enough as the main functionalities of the Pandas is data frame and the head, tail, and the describe function, and, and enlarge the shape function. You can see or you can check any part of your data using these functions. Data frame is the most important functionality of the Pandas. Now I think it's time to move forward. We will see more functionalities in our videos, future videos. Now, after the key operations of Pandas, let's move forward. It's time for the connection. This is the most important part to remember. NumPy and Pandas are a team. They are built to work perfectly with each other. You will use Pandas to do the high level work organizing your data, selecting what you need, and getting it ready. Then, when it's the time for some serious number crunching or heavy duty maths, Pandas relies on the speed and the power of the NumPy behind the scenes. They are a perfect duo for any data task. As I have already shown you how the Pandas and NumPy function works, so you can imagine how you can do the calculations in NumPy and then or previously be- before the calculations how to set up your data set or how to make your data perfect for these calculations. Now it's time for what's next, and that's it all. You have now a solid foundation in the basics of NumPy and Pandas. But the best way to truly learn it is to get your hands dirty. I encourage you to find a simple dataset set online and try to load it into a Python data frame. The more you practice, the more the concept will click. Thank you for watching. Thank you for watching and happy coding.